Okay, so today we'll be finishing the extraction of metals. Today we're going to finish the extraction of metals, and the last thing we'll look at today is the extraction of zinc. So the key thing here is when you're taught to look at the extraction of a metal in particular, you have to look at the method that is used. But before you get to the method, you have to look at the ores in which that particular metal exists. And then you have to know which one is the chief ore. Yeah, which one is the chief ore? Having looked at the chief ore, that's when you can come to the method that is used, and then the general equations that are involved during the extraction. You go down and look at the uses. That's how you start the extraction of metals. So if you have to look at the extraction of zinc, we have to look at the ores, the forms in which zinc exists. The forms in which the zinc exists. Now, in as much as I know, there are only two ores in which zinc can exist. It's your mother was calling. Sorry, this is the call. So what I'm saying is that in the study of metals, the first thing is you have to look at the ores, the forms in which the particular metal today, looking at zinc, the forms in which zinc can exist. But zinc can only exist in two forms. The first one is called calamine. Now, this calamine is just the name of the ore. Okay, so we have to look at the chemical name as well as the chemical formula. So the chemical name of calamine is zinc carbonate. Zinc carbonate is the chemical name for calamine. Now, what is the chemical formula for zinc carbonate? We all know that zinc, the chemical formula for zinc is Zn, and then the carbonate is CO3. So that is the calamine, the zinc carbonate. Then the other ore in which zinc can exist, actually this one is what we call the chief ore. This is what we call the chief ore. The name is called zinc blende. So zinc blende is a chief ore, the major ore in which zinc can exist. And that's the ore that we use when you want to extract zinc. The chemical formula, like the calamine, the chemical formula being zinc carbonate, this one is called zinc, not zinc sulfate, but zinc sulfide. But the sulfide is coming from sulfur. So this one will be written as zinc sulfide. So the zinc sulfide is a major ore from which zinc is extracted. So far, we have looked at the ores in which zinc can exist. The first one is called calamine, which is zinc carbonate, and that is a chemical formula. The other one is a chief ore, which is zinc blende, and the zinc blende is having the chemical formula, which is zinc sulfide, not zinc sulfate. If it was to be zinc sulfate, we could have written ZnSO4, but it's not zinc sulfate, it's zinc sulfide. That's why we have the radical, which is S and not SO4. So that is the first part of the study. We have to look at the O and which one is a major O, which is called the chief O. Having known the chief O, what is its chemical formula? Now, having done so, we have to look at the extraction itself. Actually, the extraction of zinc is very, very short. The extraction of zinc is the shortest of them all, if I might put it that way. But now, we have to go back to the table that we were given the first time we're looking at the introduction of the extraction of metals. Remember, I said how fast the nature of the element will determine the method that can be used when you're extracting it. Okay, and so far we looked at three methods, which is one electrolysis, the other one is reduction by carbon, then the other one is thermal decomposition. Okay, and under reduction by carbon, there are three elements that can be extracted using reduction by carbon. The first one is iron. The second one is zinc. The third one is lead. So many times they ask questions to say which of these. They'll give you a certain number of elements. Then they ask for which of the elements that can be extracted by reduction using carbon. So any of these three can be extracted using carbon. So look at the extraction of iron. And now today we're going to look at how we can extract zinc using the method reduction by carbon. So because we are saying this zinc exists in a zinc blend, a zinc sulfide. So this zinc sulfide at some point during the stage, it has to be reacted with carbon, but in form of carbon monoxide, so that the zinc can be reduced to its pure form. But now, this process takes place in two stages. The first thing that you have to do is you get the zinc blended, which is the zinc sulfide, you roast it. You roast it in air to form zinc oxide. That's the first thing that happens. The first thing that happens is that you get the zinc sulfide, which is a zinc blend, you roast it. Now, when you say you roast it, you mean you heat it in the presence of air. And once you do that, you're going to react zinc in the presence of air. You're going to have zinc sulfide plus oxygen. Then you're going to form zinc oxide plus sulfur dioxide. I forgot to say there's also an acidic gas that is formed. Now, you can see we are saying we have zinc sulfide being roasted in air, which is the oxygen being added to this. But what happens is that the sulfur will go out. The sulfur will go out to go and combine with the oxygen to form an acidic gas. So this sulfur dioxide is an acidic gas or an acidic oxide. Okay, but before I go to explain what's happening in the equation, why are we saying sulfur dioxide is an acidic gas? It is because when this sulfur dioxide reacts with water, it forms an acid. Okay, this is called an acidic oxide because when sulfur dioxide reacts with the water, what is formed is H2SO. 3, which is sulfurous acid. So that is the reason as to why this one is considered to be an acidic gas. So with all that said, what I'm trying to say is what's going to happen is that the zinc is going to be combined with 1 atoms of oxygen from here to form zinc oxide and then plus sulfuric acid. But if you look at the nature of the equation, the oxygen on the left-hand side, there are 2. On the right-hand side, there are 2, there are 1 plus 2, there are 3. So the best thing that we're going to do here is to balance. So once we put a 2 here, oxygen will be 2 here. We're going to have 2 oxygen, but zinc also has been disturbed here. Zinc 2, zinc 1 here. We put another 2. I know we haven't done much of balancing, but I'm just trying to give you a procedure. So once we put a 2 here, the sulfur also is imbalanced. We're going to put a 2. Now once we put a 2 here, oxygen will be 4 plus 2, 6. So we're going to put a 3 here. So when they say write a balanced chemical equation for the roasting of zinc to form zinc oxide, this is a balanced chemical equation that we have to write. My next move in the chemistry field, I have to teach you how to construct a chemical equation. I now also have to teach you how to balance and reduce them to ionic equation, because that is very, very important. So that is what happens at first. Zinc blended, zinc sulfide, is roasted in air to form zinc oxide and a very acidic gas, which is sulfuric acid. Now, again, I explained the reason as to why sulfur dioxide is said to be an acidic oxide. It is because when sulfur dioxide reacts with oxygen, it produces an acid. That is the first part. So having obtained the zinc oxide here, now there will be need for this zinc oxide to be reduced to zinc. There is now need for the zinc oxide to react with carbon monoxide, so that the zinc oxide gets reduced to a pure form of zinc. And that is the second and last stage that is involved. So stage number 2 is now a reduction of zinc oxide to what? To zinc by carbon. Because that is a method that we're trying to use, that is used. So how does that go? What is a chemical equation? Most of the times the chemical equations are there to guide us what really happens. So we have the zinc oxide. Now this has to react with carbon monoxide. And what we're going to form here is a pure zinc element accompanied by the formation of this neutral gas. Carbon dioxide is a neutral gas. Eh? No, carbon dioxide is also an acidic gas. Carbon dioxide. This is a neutral gas. Carbon dioxide also is an acidic oxide, because when carbon dioxide reacts with water, what is formed is H2CO3, which is carbonic oxide. So we have got 2 acids, that acidic gases that are produced, sulfur dioxide as well as carbon dioxide. Carbon dioxide is an acidic oxide, but it's not that dangerous. Carbon dioxide is not that dangerous. That's why we can even survive in the environment where we are. But for sulfur dioxide, it's very, very dangerous and also very, very deadly. We'll start more about acidic gases when you start looking at non-metals. That's when you're going to understand them better. So that is the second equation that happens. We have now zinc oxide being reduced to zinc by the means of carbon monoxide. Now, if you look at here, zinc had the oxygen attached to it. But look at the zinc which is formed. because the zinc formed it does not have the oxygen as it had at the beginning of it. Or remember, the removal of oxygen from a compound, we have removed the oxygen. The removal of oxygen from a compound, that in itself is called the reduction. So that's where the name came from. It's called reduction 1 because the zinc has lost the oxygen. Yeah. Because zinc had lost the oxygen. Not only that, if you write this in ionic equation, we're going to have zinc 2 plus, okay, then to form zinc, zinc 2 plus, plus 2 electrons, and then to form zinc. So reduction in the oxidation state from plus 2 to 0, that in itself is also called reduction. So this is a reduction process because the nature of the equation that leads to the production of the final pure element of zinc is a reduction process. So that is how this process is done. But there's an important tip that you have to note. There's an important note that you have to take. This process itself called reduction, aluminium cannot be used. They like asking that question. So you have to note that we cannot use aluminium, aluminium oxide. We cannot react it with carbon monoxide. Why? We have to look at the reactivity of the entities in here. Aluminium is more reactive than carbon. Therefore, carbon cannot remove the oxygen from itself. Okay, that may sound a bit strange to you because we haven't yet looked at the reactivities of elements, and that's the point we'll get to. But all in all, this reaction cannot happen. So when they ask you a question to say, explain why aluminium cannot be reduced by carbon, it is because aluminium is more reactive than carbon. Hence, it can not be displaced. Displaced from its compound. Yeah, so when they ask, say, aluminium cannot be extracted by reduction of a metal by carbon, why? It is because aluminium is more reactive than carbon, and because of that, it cannot be displaced from its compound of aluminium oxide. Any questions? Hello? Okay, so that is how that goes. Now, having looked at this, we have to look at the uses of aluminium. When this the uses of zinc. When this zinc is extracted, when this pure zinc metal is gotten from its ore of zinc blended, where do we use it? Okay, so we have to look at the uses of zinc, because we are done with extraction. So there are two methods, there are two stages that are involved. The first stage is the roasting of zinc blended in air so that the zinc sulfide is converted to zinc oxide. That zinc oxide itself is the one now that will be subjected to the actual reduction. You react the zinc oxide with the carbon monoxide so that carbon dioxide is produced as a byproduct together with the zinc metal. Now, when you get this zinc, where do you use it? So we have to look at the uses of zinc. The first one, this zinc that you see, this zinc that you hear of, is very important because there are times when the job that you want an item to perform, it is very tough. Okay, it sounds ambiguous. How do I put it? Let's say, for instance, you want to cut an item which is very hard. Okay, you want to cut a metal. You want to cut a metal using a grinder. Okay, you cannot use a soft element. You cannot use a soft element for cutting a metal. Okay, so you have to use something harder than the metal that you're going to cut. Now, the pure iron itself is not that strong. So if you want to use an iron to cut something and then you want to increase the strength of iron, what happens is you combine that iron with another element so that the properties of two elements are matched together to increase the strength of the item. So what am I trying to say? What I'm trying to say is that this zinc is combined. Zinc plus copper. They combine zinc and copper to form an alloy. And the name of this alloy is called brass. So the brass is an alloy which is made by the combination of zinc and copper. So they make that brass so that the properties of zinc and the properties of copper are combined together in one item. So that's the first use is that zinc is used in making of brass. Now, how do they make brass? Brass is made by combining zinc and the copper. That is one. Two, where do you use this zinc? Iron itself, the iron that we looked at the other day, its extraction, iron is very soft. The pure iron is very soft. And the pure iron can rust very fast and very easily. So now, if you want to prevent the iron from rusting, what they do, they do what we call galvanizing. Now, what is galvanizing? Galvanizing is where this is the copper that you want to protect. Then you get to have traces of zinc coated around an element that you're trying to protect. If you want to protect iron, what you're supposed to do is you get traces of zinc and coat around the element that you're trying to protect. And that's what we call galvanizing. So we do that so that this either iron or steel is protected or is prevented from rusting. So what we do here is zinc is used for galvanizing of either steel or iron. Why do we that? Do that to prevent it from rusting. So when you want to prevent the iron or steel from rusting, what we're supposed to do is to galvanize the steel or iron. What do we mean by coating traces of zinc around the element that you want to protect? That's what we call galvanizing. The third, there are many uses that you can look at. There are many uses that are there. But the third, we can look at this zinc also is used for making iron. No, not iron. It's used for making roofing sheets. Okay? And we can use the same zinc for making roofing sheets. So they will ask to say, where do we use the zinc? Okay, so we can use the zinc also for making iron sheets. Are you okay?
Yes.
The last one, where we use zinc can also be used in the making of cells. Okay. Now there are two types of cells that I would want to bring to you. these cells that are found in phones, these we call them dry cells. Why dry cells? It is because inside of such batteries, there is no acid. Okay, the acid is there, but the acid which is put in there is in powder form. So batteries that contain powdered acids are the one we call dry cells. So in making of dry cells, what we use is zinc. Now, if they are not dry cells, what other types of cells? We've got wet cells, those that you put in the car battery. When you open the car battery, the cells of that battery are dipped inside of an electrolyte, which is an acid. But the ones that are found in phones do not have liquid acids, so those are called dry batteries. So that's where we can use the zinc, but there are many more uses that you can look up to. You can Google and you get to learn more through self-study. So that's where we're going to end today for the extraction of zinc. That means we are done. We started with the extraction of iron, we went to the extraction of aluminium, we looked at the extraction of copper. Now this is extraction of zinc. There are only 4 methods, there are only 4 elements that you'll be allowed to study in your science. Paper 2, which is 5124/2 in your science. There are only 4 elements that you will be taught to study. So any questions? Because I've already sent you work that you'll be working on. Any question?
Sir.
Yes, my friend.
Sir.
Yes, Molly.
Will you please send the notes for like copper and stuff? Those ones I wasn't there, so I don't have them.
Oh, okay. I will definitely send them off.
Okay.
Any questions from what is being presented here?
No, it's fine.
Okay, the work is already there. But look at the same solutions you had sent to your auntie. Let me also have them direct from you, because the one that you had sent, I think the quality is a little bit reduced.
What?
I'm saying that the solutions you had sent to your auntie, also send them to me.
Okay.
Bye.
Bye, sir.